Hello guys, how are you doing? I hope you are fine. So this is the number two question. I'll be doing two things today, so just make sure you finish the video because after this number two question using Kirchhoff's law, I'm going to electric potential. Electric potential. So please try and watch the electric potential aspect. Now we are now let's label it. This is the longer part of the battery. So you know, as you always know, it's going to be positive. The shorter one, shorter length will be negative. So now I told you when your current will always flow away from the positive terminal, like in the direction of the positive terminal. This are we together of the battery. Now I told you whenever a current is coming, the first point you meet will be plus. Why? The reason is that this is a resistor. A resistor resists the flow of current. For you to have like sign, the same sign alongside, that's repulsion, resisting. So this is resisting the flow of the current. So that's why it will be like that. So we have our I1 here in this direction. Don't forget this place is not I2, it's still I1 in this direction because every current that is here also comes through here. It's just a single channel. So when it goes to this junction, it's split into two. I2 entry here, then I3 coming downward. Are we together? So this also plus minus. Your current is coming. Please, this is your resistor. This is where your current is coming from. It's coming. When it goes to this one will resist it, plus minus. The first point you made plus. So as it's going like this, when it gets to the resistor, no current enter here. This also is what? Plus minus. This is a battery. You all know this will always be plus. The shorter one will always be minus. So this I3. I3 is coming down. Plus minus. Are we together? Don't forget, this is still I3, not I4, please. Because every current here still come to this place. So as I3, not I4 rather, this is I3. So as I3 is coming, this is what? Plus minus. This is a battery. Normal. This plus minus. This is also a battery. This minus and this plus. Now can we move on now? This loop 1. And this what? Loop 2. Please note, this direction of this loop, this clockwise direction, is not expedient. You can decide to use anti-clockwise. In the most you follow the concept, you get your answer. Now let's move on. From our case here, we all know that said current entering a junction, which is I1. I1 enter this junction equals to current leaving the junction. I2 is leaving it. I3 is also leaving it. Equals to I2 plus what? I3. I1 is coming, enter this junction. So I2 is leaving, I3 is also leaving. So current entry junction equals to current that leaves the junction. That's first. Now from our KVL, using the loop. Now from the first loop, loop 1, the loop is going this direction first, then downward, then like this. But for this direction first, the loop, I'm not talking of flow of current, the loop now, the clockwise direction of this loop is first going like this. So relating that to this voltage, that's from minus to plus. So that's voltage rise. Negative to plus is going to be what? That's plus 12. Okay, that's 20. Plus 20 volts. So when we get to this resistance, now we have a current here, I1. I times R, that's voltage again. So everything we are calculating, everything we are using there, they are voltage. It's because KVL says the sum of all the voltage in that circuit, in that loop, using that loop, the sum of all the voltage equals to 0. That's what KVL is talking about. So because someone will see R, we see I, he will be telling you, how is this voltage? This voltage, I agree, but how is this voltage? I times R is also voltage. So take note of that. So we have 20. Well, this is plus to minus. So that's voltage drop. Your answer is going to be negative. So we have I times R. That's minus 3 I1 Coming to this side, we still have I1 there. It's dropping, plus to minus, minus 2 I1. So coming to this side, no longer I1, this I2 now. Okay, but we have this voltage first. It's dropping, plus to minus, minus 12 volts. We have plus and minus. I2 pass through here. So 4I2 minus 4I2 equals to what? Is 0. Equals to 0. Are we clear with that? Sorry. Equals to 0. Now, now 20 minus 12 is going to give you 8, right? Equals to minus 3I1 minus 2I1. That's minus 5I1. But when it goes to the other side, it becomes plus 5I1. This is minus 4I2. When it goes to the other side, it becomes plus 4I2. For loop 2, are we together? For the second loop, this is it. Please, this 4 and this 12, they also have impact in loop 2 as much as they have impact in loop 1. Please take note. They don't only belong to loop 1 because loop 1 and loop 2, they are sharing this line together and communicating. So now, you can see the loop, the arrow is like this, going like this, then like this arrow. So from here, though this drop for loop 1, but for loop 2 is going to be rise because the arrow is like this, minus to plus. So this is going to give us plus 4I2. We have I2 there. Then the voltage, that 12 voltage too, minus to plus, plus 12 voltage. Now as you get to this point, this loop, it also come after going like this, it will come like this. Are we together? Well, here we have plus to minus, that's drop, and we have I3 there and 6. So that's minus 6I3. Coming like this, still I3 here. Here we have a volt, plus to minus, that's minus 6 volt. Then this plus to minus, we have I3, that's drop, minus 10I3 equals to 0. So here, it's going to give us 12 minus 6. No, oh, sorry, that's not the end. Here we still have, this loop is still going up like this. So we have 18 volts here. Plus to minus, that's minus. Drop. Minus 18. Minus 18 equals to what? 0. Are we together? So let's collate everything. 12 minus 6, that's plus 6. Minus 18, we have minus 12, Abby. So here we have minus 12 plus 4I2 plus 4I2 minus 6I3 minus 10I3, that's minus 16I3 equals to 0. So here we have 4I2 minus 16I3 equals to minus 12 comes to the other side to become plus 12. Are we together? Now bring this one down. This is our equation 3. This is our equation 2. Yeah, bring down equation 2. Equation 2 says 5I1 plus 4I2 equals to 8. This is our equation 2. So now we are going to solve simultaneously, but before that, we are going to solve. Here we have 3 and 2, here we have 1 and 2. So we have to make the unknown to be equal. You see that 2, 3, you have 2, 3 here and also 2, 3 here, or you have 1, 2 here and also 1, 2 here. So let's substitute I1 equals to I2 plus I3 into this equation 2 so that we can have 2 and 3 alone, just like equation 1. So from equation 2, we have 5I1. And what's our I1? I2 plus I3. I2 plus what? I3 plus 4I2 equals to what? 8. So it's going to give us 5 times I2, 5I2. 5I2 plus 4I2. That's 9I2. 5 times I3, 5I3 plus 5I3 equals to 8. So let me bring equation 2 and 3 together. So here I'm having this equation 3, which is what? 4I2 minus 16I3 equals to 12. The equation 2, we have changed it to this now. 9I2 plus 5I3 equals to 8. So this is simultaneous equation now. You can find our I2 and I3 simultaneously. So this multiplied by 9, this multiplied by 4. using the coefficient of I2. The second equation multiplied by the coefficient of I2 in equation 1. The first equation multiplied by the coefficient of I2 in equation 2. And you can decide to use this. So this one will be times 16. This will be times 5 if you are using I3. And then times 4 I2, we have 36 I2. This minus 9 times 16. 9 times 10, 90, 9 times 6, 54 plus 90. That's 144 I3 equals to 9 times 12. 9 times 9, that's 99 times 2, 18 plus 90. That's 108. All together. 4 times 9, 36 I2. 4 times 5 plus 20 I3 equals to 4 times 8, 32. So you subtract. If you subtract, this guy cancel. This one will change to plus because you have minus and minus. Like, okay, don't worry. This minus 144 I3 minus 20 I3. It's not changing to plus. Sorry for that. Minus this, minus this, minus this. That's going to give us minus 164 I3 equals to 108 minus 70 minus 32. That's going to give us 76. So here we have I3 equals to 76 over minus 164. So our I3 equals to minus 0.463 ampere. So you divide this by this, you get this. Now substitute this to either this or this. So you substitute to this or this, you still get the same thing. So to get your I2, if you do that, your I2 will give you, that should be 1.146 ampere. So you can use this 2 to get your I1. Your I1 equals to what? I2 plus I3 equals to 1.146 plus, what's our I3? Minus 0.463. So, this with plus times minus, that's minus. So you are subtracting. At the end of the day, your I1 will give you 0.683 ampere. That's your answer. Are we together? So that's the answer. I3 this, I2 this, then I1 this. The beautiful thing is that if you decide to use this as your loop 1 and this as your loop 2, and you decide to, to use the direction of this current to get maybe your I1 come like this, then I2, then your I3 go like this, you still get your answer. You still have your answer. So that's that for that. Now I'm moving to potential this thing. Now, for this particular aspect, I'm coming. Please take note. It's very simple. Once you get it, it's like a bonus. When you have your direction of Q to be negative J, another word for negative J, negative Y axis. Another word for positive J, positive Y axis, negative Y axis, positive Y axis. I is X axis, but J is Y axis. So if the charge Q is going along negative J, they will tell you a charge Q is going along the negative J. A positive charge Q, if the charge is positive. Or they may not say positive, they may say greater than 0. So anything greater than 0 is plus. If your charge Q is greater than 0, this positive, let me put it greater than 0. This is also greater than 0. So this less than 0. This also what? Less than 0. So it can be that of the two. When you have a positive charge going along the negative Y axis, what will be the sign of your change in displacement? Now, this is the formula. The work done by an electric field equals to what? Minus change in potential energy. Are we together? I know potential energy now. Potential energy is mgh. mgh. This time, let's represent our h with r, both at distance. So potential energy, this change in potential energy is going to give us minus uh, mgh. But our h now, this change is the I that is changing. Still the same mass, still gravity is the I that is changing, changing r. Are we together? So is equal to minus mg r final minus r initial. Are we together? And you know that F equals to mg, Abi. You also know that F equals to QE. Don't forget this now. Electric field intensity is equal to F over Q. Force per unit charge. This electric field intensity equals to force per unit charge. If you cross multiply, your F give you QE. So that's it. So if F is mg and F is QE, that means wherever you see mg, you can replace it with QE because both are F. So this guy can actually give you minus QE. Are we together? R final minus what? R initial. So that's the formula. Please take note of this. So we want to know the sign of this displacement, the sign, this change in displacement, the sign of W, work done by the field, and the sign of our potential energy, change in potential energy, whether it's positive or it's negative. So how do we do that? Now, please take note. I'm going to change this into 3 brackets. So for the minus Q, put it as a single bracket. Please, this minus is in the formula. This minus is in the formula. Q may also have its own sign. It can be positive, it can be negative. If Q is negative, then you have 2 minus here. So just change it to one bracket. This E, this E, this E, this is it. This E, yeah, the E here, this E. Change it to a single bracket too. And this RF minus RI, RF minus RI, change it to a single bracket. Are we together? You are multiplying the 3 together. So this one, first write this minus. Don't eat it. It's in the formula. It's not in the question. It's in the formula. Don't eat it. So you have minus here. Are we together? So now, here, your Q is greater than 0, right? Your Q is positive. So this single bracket will be minus times Q. It's minus Q. Since your Q is positive. Are we together? So please, this one, this E is always use positive always. Are we together? Positive. In any of your questions, use positive always. So this one too. Now, is going, how do we get the sign of this? Is it positive or negative? How do we get it? Now, this thing is going along the negative J axis. Negative J. You don't have to stress yourself. When you see that it's going along the negative J, the sign will be negative. How do I know? Now, this is the axis. This minus X minus I plus J minus J. So it's coming like this. Maybe it's coming from here or from here or from here or from here. I don't know. Since it's going along the negative J, this down will be the final where it will stop. And whatever point here will be our initial. Don't know. Whatever point will be our initial. Are we together? So if the initial height is higher than the final height, is coming along the negative J. So whatever point here will be our initial height. So going to the negative J will be our final height. So if your initial height, you can see, is higher than the final height, then the change, since the change is final minus initial, which means initial is smaller. Final is smaller rather, initial is bigger. So smaller minus bigger, you get a negative value. But you don't have to stress yourself with this. When you have negative J, going along negative J is going to be, the sign will be minus. Along, not opposite negative J. When we get there, you know. When it's going along the negative J, this will be. So times. Minus times plus, you have minus times this plus, right? Minus times plus, you have minus times this plus, right? And this minus times minus. Minus times plus, that's minus. Minus times minus, that's plus. All the formula here is equal to work done. Don't forget. This is what we did. W equals to minus QE, and this minus QE, and this. So everything is equal to work done. So when we do everything, what do we get? Plus. Eh? So our work done is what? Plus. Positive. This one is negative. We've decoded that. Wow, this is negative. So now you're changing you. Always note, whenever your work done is positive, from the formula, work done is opposite changing you. If this one is plus, this is minus. For this one to be minus, if this one is plus, this minus. Are we together? For this one to be minus, this one have to be plus. They are opposite. They are opposite. Am I communicating? They are opposite. So whenever this guy is plus, this guy will be minus. So since our work done is plus, then this guy is going to be what? Negative. So now for the other one, this positive j. This positive j. So we say work done equals to minus QE, change in RF minus RI, which is what? Minus Q. What's our Q here? Greater than 0 times positive, right? Times this our E, always use positive, like I said, times now your RF minus RI. Since it is positive J, this is going to be plus. Another time in the question, they may not tell you positive J as is, they will tell you opposite negative J. When something is opposite minus, that means that thing is plus. So at the end of the day, minus times plus, that's minus, times plus, minus, times plus, minus. So your work done is negative here. So this one is always opposite work done. So this guy will be positive. Are we together? So another thing they may ask you, when you have a negative change in kinetic, change in potential energy, what does it mean? That means your potential energy is decreasing. Negative is decreasing. When you have a positive potential energy, what does it mean? That means your potential energy is what? Increasing. Please take note. They may not use sign in your question. They may say, is it increasing or decreasing? Negative means decreasing. Positive means increasing. So this one is positive. So for this one, negative J, your work done equals to minus QE RF minus RI equals to minus, this one is in the formula, minus times, what's our charge? Negative. When the charge is negative, times this one always positive, your E always positive, times now your RF minus RI, this negative J, so this guy is going to be negative. This guy is going to be negative, equals to minus times minus plus times plus, that's still plus, times minus, that's what? Minus. Are we together? Yeah. If we have a negative, then that's minus. So your work done equals to negative. So this guy is what? Positive. This is what? Negative. Are we together? That's negative. From here, this is it. Now the last one, we have W equals to minus QE RF minus RI equals to minus, what's our Q? Negative, times negative, times this always plus, times your this, since it's going to the positive J. See that they say along positive J axis or opposite negative J. They can change this to opposite negative J. When anything is opposite negative J, that's positive J. So they may not put positive J there, they may tell you opposite negative J. If it is along negative J, that's negative. Along positive J, that's positive. But if it is opposite positive J, that's negative. If it is opposite negative J, that's positive. So this is just positive. At the end of the day, you have minus times minus plus times plus plus times plus plus. So it's going to give you what? plus. Your work done is what? Positive. This guy is what? Negative. This guy is plus. This change in displacement, positive. So this one means decreasing potential energy, increasing, increasing, decreasing. Please, this one doesn't mean increasing. This work done. Are we together? This work done is the work done here now, positive, is in the same direction with the field. Ehen. The field will always be along with the positive side. This one is it opposes the motion because it opposes the motion. This one is alongside with the motion, same direction with the field. This one is it opposite the field. It oppose the motion, same direction with the field. So that's that for that. Thank you. Thank you for listening. Do well to like and subscribe. Good day.